Today we'll solve another sum of the series problem. I will explain to you step-by-step process how to solve this. So this is a series sum we need to find out. If you observe in this series, you can notice that first we need to find for any sum of the series in this problem sessions, right? We need to find the nth term, like right, any term, okay? Just replacing 1, 2, 3, 4, 5, right? We'll get that corresponding terms. For example, this is the first term, this is the second term, this is the third term. The first term, if you see right here 1 square and 1 to the power of 4 here. If you see the second term here 2 square and 2 to the power of 4 here. So that way in general nth term can be written like n by 1 plus n square plus n to the power of 4. Okay, if you substitute the 1, we'll get the first term, 2 if you substitute the second term. So this is general form for the any of the term in the equation. If you see this equation, how do we usually will solve, right? We need to do the factorization for this term. How do you get the n to the power of 4 and n square plus 1 terms? If we just do the whole square of n square plus 1, we'll get the one term as like n to the power of 4, another terms like n square, another term like 1. That's the reason what you do, right? We do just to take the n square plus 1 whole square. That is a plus b whole square, right? So that's corresponding n square whole square plus 2 into a into b plus 1 square, right? So if we further simplify it, we'll get 10 to the power of 4 here and 2 into n square and plus 1. If you look at this term, right, we have 1 plus n square plus n to the power of 4 over here. So that we'll split this term to the two terms, right? So here I split this one 1 plus n square plus n to the power of 4. We have another n square here, right? So I'm setting that n square to the other side of the equation so that it became minus n square. Okay. So I just swap the left hand side and right hand side here so that we have 1 plus n square plus n to the power of 4 equal to this term. So this looks like a square minus b square, right? So that we can write a plus b into a minus b. Okay. So now finally we found the factors for this denominator term right here. So now what you'll do, right? I'm just taking this term here and trying to simplify it. So I'm just taking the entire term over here, and if you put n by, the factors for this two is these two terms, right? Now here you need to notice something here, okay? If you subtract these two terms, this factors term, okay, you are getting the numerator, okay? Then you can do the sum of the two fractions, okay? How you can do the two fractions you see here? If we just do the 1 by n square minus n plus 1 minus, right? So this is a smaller number compared to this, right? When the denominator is smaller, the overall it will become the larger number, okay? That's why I'm putting the first term this one. Put minus 1 by this, right? So what happened? When you take the LCM here, these two terms will get it into the denominator as it is, and the numerator, this term will go here and this term will go here, right? Then n square will get cancelled and 1 will get cancelled, and this n minus of minus plus n, right? So it will become 2n. So 2 is not there right here, right? That's the reason I'm putting 1 by over 2 over here. So that the 2 get cancelled, and finally it will become this term, okay? So we did the fraction sum for these two terms, okay? In this here, if you take common here from the first two terms, okay, so that it will become n into n minus 1 here, and here n into n plus 1 here. Finally, the generalized form of this term, right, we convert into sum of the two fractions here. So let's take problem to be found under the generalized form of the nth term, and that we converted to the sum of the two fractions here. Okay. Now let's substitute 1, 2, 3, 4 and so on up to 50 into this above series. Okay. So if you substitute here 1, okay, 1 into 1 minus 1 plus 1 here, right? Minus 1 by 1 into 1 plus 1 plus 1. Okay. Similarly, we substitute 2, 3 and so on until 50 number. Okay. So if we simplify further, this just comes like 1 by 1 minus 1 by 3 here from the first term. From the second term, we have 1 by 3 minus 1 by 7 and so on. And this is the 50th term, okay. So if you notice here, right, if we just take out the common 1 by 2 from all the entire series, okay. If you take out the common 1 by 2, you can notice that, okay, this 1 by 3 and this 1 by 3 will get cancelled. So minus and plus. Similarly, this minus 1 by 7 and plus 1 by 7 will get cancelled. So that it will keep get cancelled all the terms till this term, okay. Finally, we have the two terms in this equation, that is 1 here and minus the last term over here, okay. So if we further simplify it, so this is a 2551, and if we take the LCM, 2551 minus 1 by 2551. If we do further simplification, it's 2550 by 2551 half of it, okay. So final answer for this sum of the series is 1275 by 2551, okay. So we just try to do the factorization for this series is always, okay, so that the many of the terms will get cancelled and you can simplify the term very easily, okay. So thank you for watching. If you have any questions, write in the comment section, and if you like the video, press the like button and share with your friends. Thank you.